Now we'll look at doing vector operations symbolically. So instead of listing out the rules, sometimes it's just easier to watch a few examples and then you'll get the hang of it. Most of these work how you'd kind of want them to work. So if we wanted to add two vectors together, so in this case, u plus v, how could we do that? Well, we're just going to add the components together. So we're going to add the first components together. So in this case, 3 plus -1, and then add the second components together. So -2 plus 4. So this gives me 2, comma 2, and I'm done. So similarly with u minus v, we're going to say take the first component of u, subtract the first component of v, and then the second component of u minus the second component of v. This gives us 3 plus 1, so 4 minus 6. 3u is just a scalar multiplication, so it's multiplying both components of u by 3. So 3 times 3, comma 3 times the -2. This gives me 9, comma -6, and done. If I had 1/2 v similar, I'm just going to take both components of v and multiply them by 1/2. So v has a -1 and a 4. Simplifying, we get -1/2, comma 2. For negative u we know is just -1 times u. So it's a similar of just multiplying both components by -1. So u is 3 comma -2. So this is -1 times 3 and -1 times -2. Simplifying, we get -3 comma +2. For 2u minus 3v, a few things are involved. We have scalar multiplication of both u and v, and then we have a subtraction. But we can still do it kind of all in one step. So 2u is going to look like 2 multiplied by both of those components, minus 3v, so this is just 3 multiplied by both of the v components. So then I'm just going to plug things in. So for u, I have a 3 and a -2. And for v, I have a -1 and a 4. And then I just go from there. So this is 6 comma -4 minus -3 comma 12. And now I just need to subtract. So what does that mean? Well, you're really just subtracting by components, right? So 6 minus a -3, and then -4 minus 12. This ends up being 6 plus 3, -16, or 9 comma -16. And then I'm done. So that's how we can do these vector operations symbolically.